right, so what we're looking at today is a different law. Okay, so the cosine law. Now, to understand how to tell when a situation requires the law of sines and to apply it to find sides and angles in a non-right triangle. Okay, so that's our goal for today as well as for tomorrow. We're still going to be working with the law of cosines. Now, the law of cosines is used in places where the sine law just doesn't work. Because remember in the sine law, you need to have one angle and its opposite side in order to have numbers on the top of the ratio and the bottom of the ratio. And if you don't have that, you just can't use the sine law. So we're left with kind of a dilemma. Um, so that's when we use the law of cosines. So the two places that the sine law are no use to us are the following. One, where I am given two sides and an angle in between. Sometimes I call this Pac-Man if I put my hands together. It's the angle that holds my hands together when I'm clapping. So that is one instance that I do not have anything I can do with the sine law. So if I know this side and this side, and obviously the angle in between, sine law doesn't work because I need to know an angle and the side directly across. The other instance that sine law is no good to me is if I am given all three sides. In fact, if I know all three sides of a triangle, there's only one triangle that would have that you could make it this way. Okay, so it's not that you can have a million triangles with the measurements 18, 24, and 26. It just doesn't work. So those are when we have all three sides with known values, or if I know two sides and the angle that holds those sides together. So we're introduced then to what we call the cosine law. And I can use the cosine law for these two types of situations. So in red it says, if in triangle ABC, sides A, B, and C are opposite angles, A, B, and C, okay, and that's the same way that it was when we did the sine law, the following property holds. C squared equals A squared plus B squared minus 2 times A times B times the cos of C. And it's really important for you to note that the A and B are sides that make up the angle, and obviously you can't see that because I've done it in red. So I guess it means I need to go and get a black pen. Okay, so are the sides that make up the angle C. Okay, so just like up in this situation, I know these two sides, A and B, and C is the side that makes up those two sides, and this would be little c. So I can use the formula to find this side length C if I know angle C. Okay, now another thing, if you notice I've got a star here, or if we arrange this situation, we can use it to solve for an angle. So one way we can do this, okay, and I'll be honest with you, after we do this now, rearranging, I will give you the formula for finding with if you have all three sides. Okay, so but we will go through it right now. So if I take my original, which is c squared equals a squared plus b squared minus the 2ab cos of c. Okay, so I want to take this and I want to rearrange it for cos of c. So the way that we do that then is the following. I'm going to subtract a and b from both sides. That makes sense, right? Um, I could subtract them, or I would have to subtract two things. I think maybe what I'm going to do is I'm going to add 2ab cos of c to both sides. And you're saying, how come she changed her mind? Well, there's many different forms of any one formula. and I'm just thinking it might be easier this way. So now what I have on this side is I have c squared plus the 2ab cos of c equals a squared plus b squared. Now we're almost finished. Okay, so now remember I'm after cos of c by itself. So I'm going to subtract c squared from both sides. And when I do that, I end up with 2ab cos of c equals a squared plus b squared minus c squared. And now I almost have cos of c by itself. I'm going to divide both sides by 2ab. And what we're doing right now is what they do actually when they make formulas up. They take one and they rearrange it to something that's more useful for them, especially if they were finding a lot of angles. It would make sense to rearrange it. So we almost have it finished here. We've created a new formula where it says the cos of c equals a squared plus b squared minus c squared. So it's important that you're subtracting the side that goes with the angle you're finding, all divided by 2ab. Okay, so it's kind of a monster formula, but it comes in very useful, believe me. All right, so on the other side, so here we have two versions of the cosine law. One for sides, okay, one for angles, and for the sides, it's this, c squared equals a squared plus b squared minus 2ab cos of c. Or if I have all three sides, cos of c equals, and if you notice my 2ab got moved away from us, so it should be underneath these other three from the top. Okay, so now let's actually go and use it on something. Okay, so find the value of side C in the given triangle. Okay, so here is my given triangle. Okay, and that's the one we've been looking at all along, but now we're actually going to use it. So the first thing that I always do is I label my triangle. Okay, I notice it's not a right angle triangle because that's always important. And I label, up you come here, so this is side C, side A, and side B. I can see I need to use the cosine law because I have two sides and the angle that holds those two sides together. So I'm finding side C, so that's C squared equals A squared plus B squared minus 2AB cos of C. So now it's just a matter of substituting what we know. So A is 28. So 28 squared plus 16 squared minus the 2 times 28 times 16 times the cos of 89 degrees. Now, I'm going to be perfectly honest with you. If students are going to mess up this formula, it's going to be right here. It's going to be right at this end. These are all being multiplied together. You have to follow order of operations. Okay, so I'm going to take the 28 squared and add 16 squared to that, and I end up with 1040. When I take my calculator and multiply all of this together, I end up with negative 896 cos of 89. Remember, I am multiplying. So the more steps you have, sometimes the better. Okay, and it's just a matter of taking my calculator and actually calculating this. So it's 1024 decimal 3626. Now, if I look at 1000 for C, well, it looks like C is pretty long, but number seems to be too large, and it is too large. This was a formula for C squared. So in order to find C, I have to take the square root of that number, which when I do that equals approximately 32.0, and it would be centimeters. Okay, so always really important, always remember that whatever side you are finding is on the left-hand side of the equation, and the angle across from it is the value on the far right. So if I'm finding C, I'm using cos of C. If I was finding A, I would use the cos of A. Okay, so that's how I sometimes even write the formula down. All right, so let's go do another example. All right, so, and this is the last one for today. Solve the following triangle. Okay, well, let's see the triangle that we need to use now. Okay, so here's the triangle they want us to look at. Now, you can see I have 3 side lengths. Okay, and that was the triangle that I showed from the other 2 pages. So when using cosine law to solve a triangle, you only have to use it once. So in other words, if they told me to solve this, that means I would have to know all the sides, which I do know, and all the angles. Okay, but all I need is for the cosine law to find one of my angles. Okay, now so really what you want to use is you're only going to use the cosine law once, and then you'll have an angle across from an opposite side, and then you can use sine law, which is actually faster, less chance of making an error. Okay, but remember with the sine law, you should never use the largest angle. Okay, so how do I know which angle here is going to be the largest? Well, the angle that we should find is from the biggest side, because across from the biggest side is going to be the biggest angle. Okay, so I should find angle B. If I find angle B, it will be the biggest of the other two, and then I can use the sine law and not worry about making an error with the sine law. Okay, so I'm going to stop it quick, just so I make sure that I have enough time to get through this. Okay.